everybody. Welcome back to physics. Happy Monday. So I think that we got to a really good point with kinematics in two dimensions, which is what we were doing before COVID started happening and kind of during the review stages prior to spring break. A lot of time passed during spring break, and I feel like we got to a really good place with kinematics in two dimensions. So I'm going to have us continue on and start our new unit today. There will be a small quiz at the end of this week on Newton's 3 laws, and there will be a slightly larger assessment at the end of next week on forces in general and Newton's 3 laws. The following 2 weeks, we'll spend some time working on your big independent research projects, and that's kind of the plan for April. We'll plan out for May as needed depending on what's happening with COVID. Okay, so what are we doing today? Today we're going to start with Newton's first law of motion, and my goal for you is that you can apply Newton's first law to real-world problems and situations. Okay, before we can actually discuss what Newton's first law is, we need to talk about forces since that is the title of this unit. So, in simple terms, a force is really just a push or a pull that causes a change in acceleration. In order for an object to move from one place to another, it needs to be accelerated. Okay, for example, this lamp is currently not moving. In order to make it start moving and move from one place to another, I need to apply a force to it in order to make it move. And I can use that force to accelerate and deaccelerate the lamp. That's effectively how forces work, a push or a pull on an object. Okay. So, Newton's first law basically states that objects in motion stay in motion. This lamp will stay in that spot for eternity unless it is acted on by another force, like that. Okay. So objects at rest tend to stay at rest, and objects in motion tend to stay in motion. A great example of that is when a car is driving down the road, it will continue to coast for a very long time even if you don't apply any gas to it. It'll just keep moving forward. Eventually it will start to slow down either because of hills or because of frictions between the tires and the wheels and the inner mechanics of the car itself. But in a frictionless environment, the car would actually continue moving on forever at the exact same speed in the exact same direction unless acted on by another force. Okay. So what are some examples of Newton's first law in the real world that we can do? I'm going to do one example demonstration, and then I'm going to have you guys try one practice. All right, so this is a very famous Newton's first law demonstration. It's one that I encourage you to do with your families at home, especially young children. Really like this one. It does have the possibility of making a little bit of a mess, but as long as you're kind of doing your homework and you've got your right materials and you demonstrate it properly, you should be able to do this without making a mess. I've got a cup with some water in it, and I've got an object that is very thin and very smooth. I'm using a Ziploc bag for this demonstration. Wax paper works well. You can also do it with aluminum foil. Those are just a couple of other options. Okay, so what we're going to do is we're going to place our Ziploc bag on the table. We're going to place the water on top of the Ziploc bag, and I'm going to pull the Ziploc bag out from underneath the cup of water. So, take a moment, predict, is it going to move, not move, move a little bit, and why? Go ahead and make your prediction. Think about why. All right, let's see what happens. Cool. So, it moved just a slight tiny bit, just a hair. Why is that? Why did it move just a little bit? Well, because when I pull out the Ziploc bag from underneath the table, I'm exerting a pretty strong force on the Ziploc bag. The Ziploc bag is at rest, but when I apply a force on the bag, it moves. Now, there is a little bit of friction between the Ziploc bag and the cup. And because there's a little bit of friction, that little bit of force that I'm exerting on the Ziploc bag, a part of that also gets exerted on the cup, causing it to jump forward just a hair of a bit. If I pull it faster, if I use objects with less friction on them, I can make that movement even faster and better so that the cup moves even less. I encourage you guys to try this at home. Like I said, it's a really fun one to do. Give it a shot, and then answer the exit slip on our Google Classroom page. See ya.